Hi, this is Brent Raymond from the 4D Method 4D in Wakanda user group. I just wanted to put together a quick follow-up video to Jim Dorrance's demo that he did on how to create user-defined constants for 4D to use in the 4D development environment, and speak to that a little bit about how we use them at the Art Institute of Chicago here in their collection management system that they use to manage their artworks. Touching on some of the benefits of using constants rather than process variables is 4D, every time you launch a new process, it will store all process variables that you have declared in your development environment, in your code. It will replicate all of those variables for every new process that you create. So if you move a lot of those constant values into actual user-defined constants, as we'll show you later, it will speed up the process, the launch of new processes. Also, you'll use less memory for each process, which can have a real compounding effect. It will also offer you better clarity in databases with heavy numeric key usage in the tables. So instead of, say, querying for where a field is equal to the number 4, you could actually have a verbose text constant value that makes it much easier to read, and yet you still have the added speed benefit of storing everything with keys, and your data size is much less. It's much smaller. So stepping back, we'll talk a little bit about how it used to be done, because this has all gone through a bit of an evolution in the past few years. In the early days of 4D on Mac and Windows, 4D would utilize a resource fork, the RSR file. People could store their own resources, text and numeric resources, string and numeric resources, in the RSR file, and edit those using the programs ResEdit or Rezilla, and so then those resources would show up as constants in the same manner that 4D's constants do in the development environment. Since a while, 4D has recommended to not store your resources in the RSR file, but to migrate them to a plugin stub and store them in the RSR file of the plugin itself. Now the resource fork has completely been abandoned for such uses, and currently the recommendation is to store them in an Xlift file. Xlift, I'm not sure what that stands for, extensible something something something. It is XML, as you can imagine, with an X. Old resource files can be automatically migrated to Xlift with 4D Pop, and we'll take a look at 4D Pop. So let's go ahead and bring that up. Let's see. The Xlift Constants Editor right here is a small application that I made for the specific purpose of editing our constants. You can bring up 4D Pop. It is a component that's free from 4D. It's actually a series of components that are all integrated into one component viewer menu here. I have it slimmed down just to show the ones that that we use on a regular basis. And you see here there's an option to see constants. We have a user constants Xlift file, which in fact is the file that was automatically generated by this 4D-pop component from our old resource fork. So it was actually completely effortless to transfer all of our old constants into the Xlift file, and that's always good when you don't want to spend more time reinventing the wheel. All of your resources are, all of your constants are organized into themes. They can be, more themes can be added with this button. More constants under a theme can be added with this button here. I'll just show you a quick example of that. New theme. Okay, we just made a new theme, and we'll make a new constant under that theme. Hi. That's how it will appear in 4D. So we're not going to save that, but you can also go through and browse what the what constants are in your file and what their values are. The type auto is just a way for it to determine if you want to force this value into a string. You can do that here, but otherwise it will automatically determine what type it needs to be. Now what this 4D-pop is doing is automatically editing an Xlift file, which is, as I mentioned, XML. Let's take a look at that real quick. So again, it's just a bunch of automatically generated XML. That's a hierarchical file that is formatted in a way that 4D can read it. Here you see the groups of themes all under a certain list, and it goes on and on. Each of them have their own UUID and their name and particular other name, internal name that's associated with them. But in the end, all that you're going to see in the user environment are these names, which are completely under your control to set what they're, how they appear in the development environment. So without too much more detail, this is the file that gets generated. Yes, it is possible to create and edit this this file by code. However, if you're just starting out creating constants for use with your databases, you might find it easier just to use the 4D-pop editor and keep things simple until you have more complex needs. Okay. So right. So the Xlift files are primarily used for multi-language applications. They store translation texts, but makes it very easy to put your constants in the Xlift file, and that way you can actually have different Xlift files with different values of the constants per if you're going to use this constants file with different databases, so as to customize your application to, say, different customers. Right. So so then in practice, what we do is we edit the constants in our constants editor application, Xlift constants editor, in 4D-pop. We're not going to save those modifications. You can also browse the constants in the Development Explorer here. It will not only have 4D's constants, but it will show you what constants that constants families and constants that you've created, and it will actually show you the the value here. So we edit this the constants in this this database, and then we go into the database and show the package contents. The Xlift file goes in the resources folder, and we then take this file and propagate it out to our production and development environment. It's good to keep track of versions of these files, just like you keep track of versions of anything else. Let's see. It is also possible to see the value of a constant in the Runtime Explorer. Sometimes that's quicker than actually going in and finding it in the Explorer or looking it up in 4D Pop. So you can see here, you can just drag one in or copy paste it into your Runtime Explorer, and it will show you the value. Unfortunately, in the method editor, it doesn't pop up with help text for what the value of a constant is, and I think personally that would be a very helpful feature to have in 4D for future versions. Wink wink 4D. That would be very nice. Right, so as you might notice, in our database we have lots and lots and lots of constants. In fact, we have thousands, over 5,000 constants. What do we use them for? We use them for a whole variety of functions. For instance, we have see here a method that takes a parameter. You pass a series of one of these constants to the method, and then it will it shows a list here in the comments of which constants are acceptable to pass to this method, and then it will do what it needs to do, and in this case return to you a label for the mode that's associated with each of these constants. Our application has a what we call a virtual structure with virtual fields and tables, which is something I'll cover in later videos. It's actually quite interesting. But each of our fields is represented by a constant name. So you can see it's in the object virtual table, and this is a virtual field named artist name. And this is actually where we're registering the virtual field and giving it a textual name that will be displayed to the user. There are lots and lots of other potential uses for constants, and we find uses for them virtually everywhere. And you might ask, okay, you have over 5,000 constants. How in the world do you keep those organized? Well, we utilize a custom manager that's under constant development. There's a lot of features lacking, of course, but we throw those in as we go along. But what you can see here is you can quickly browse by a list of modules that that we have registered in our application. Here are all the object constants that we have in our database. If we just wanted to see all the virtual fields that we have registered in the application, we can see them in this manner, and do all the usual things, sorting by value, label, and whatnot. Query on how they're stored, different properties of the constants. Also clicking into a constant, and it's just doing some initialization of the database there, but of the modules. you see where you can edit the categories. We have error codes that have constants and text associated with those constants. Security privileges for who has access to which of the virtual fields. All of our preferences are stored with an ID that's stored in a constant and subsequently accessed in a table, and so on and so forth. Discrete values, those are just numbers or text that are used in different places. Anything from set names to semaphore names to process names, anything that you don't expect to change or that you could customize for other systems, or frankly you just want to see it's a number and you want to see a textual representation of that number, you can make a constant for. In this editor we can show the label, a little bit of information, what kind that it is. For virtual fields we can generate the next number of the virtual field so that you don't have to keep track of where you are. It's kind of like a sequence number. Assign the family that it goes into, and then with our virtual field registration there's a small browser down here that shows what some of the basic properties are of the field, whether it's searchable or viewable or available in a batch change. You can associate notes with each of the constants, and this is actually a feature that tests through an execute statement whether or not this constant in fact tokenizes in this database. Does it actually exist in the Xlift file, or does it need to be added? So in practice what we would do is actually create a new constant when we need one in here, because it can happen quite often, and assign it a value, and then in the method editors, wherever that you're actually working, you would go in and instead of using 4D pop on the fly and then restarting your database, sometimes it's quicker to just associate a macro with a constant that lets you know to assign a constant, to replace an actual discrete value with a constant, say an object virtual field. So right, and then once you would add a group of constants to the Xlift file, they would then tokenize, and then you'd go through and search in your database for wherever you've commented that you need to replace a discrete value with a constant. And right, so yeah, so that's a little taste of how we handle constants here at the museum. If you have any questions, let me know, and stay tuned for another video or two about our virtual structure and the advantages and disadvantages of handling your application in that manner. Thanks a lot. This is Brent Raymond from 4D Method. We'll hope to see you soon in one of our meetings.